At the smallest scale, everything begins with particles. All matter is made of tiny building blocks, particles like electrons and quarks, held together by fundamental forces. These forces are what allow matter to exist at all. Without them, atoms wouldn't form, chemistry wouldn't happen, and stars would never ignite. At this level, the universe is less about objects and more about interactions. Energy, motion, and probability dominate. This microscopic foundation sets the rules for everything that comes after. As we move to larger scales, one force becomes increasingly important. Gravity. Gravity is much weaker than the forces that hold atoms together, but it has one key advantage. It always attracts, and it never cancels out. Over time, gravity pulls matter together. Clouds of gas slowly collapse. Density increases, temperature rises. Eventually, stars are born. Stars are the engines of the universe. Inside them, lighter elements fuse into heavier ones, releasing enormous amounts of energy. This process creates light, heat, and, over billions of years, many of the elements that make planets, oceans, and living organisms possible. Stars are not permanent. They form, evolve, and eventually die. When massive stars end their lives, they scatter enriched material back into space, seeding future generations of stars and planets. Stars rarely exist alone. Gravity gathers them into vast collections called galaxies. A galaxy can contain billions or even trillions of stars, along with gas, dust, and something we cannot see directly: dark matter. Galaxies come in different shapes. Some are spirals with graceful rotating arms. Others are elliptical, more rounded and diffuse. Their shapes depend on how they formed and how they interacted with their surroundings. When scientists observe galaxies, something doesn't add up. The visible matter alone isn't enough to explain how fast galaxies rotate or how they stay together. To account for this, researchers propose dark matter, a form of matter that doesn't emit light but still exerts gravity. Dark matter doesn't clump into stars or planets. Instead, it forms invisible scaffolding that galaxies assemble around. Even though we can't see it, its influence is felt everywhere. On the largest scales, galaxies are not scattered randomly. They arrange themselves into vast filaments stretching across millions of light years, separated by enormous empty regions called voids. This structure is known as the cosmic web. Galaxies tend to form where these filaments intersect, creating dense clusters. Between them lie vast regions of near emptiness, where very little matter exists. This pattern emerged slowly, guided by gravity acting over billions of years. One of the most important discoveries in modern cosmology is that the universe is expanding. This doesn't mean galaxies are flying outward from a central point. Instead, space itself is stretching, carrying galaxies along with it. The farther away a galaxy is, the faster it appears to recede. This expansion began with the early universe and continues today. When scientists measured the expansion carefully, they noticed something unexpected. The expansion is speeding up. To explain this, researchers propose dark energy, a property of space itself that drives accelerated expansion. We don't yet know what dark energy is. We only know how it behaves. It dominates the universe on the largest scales, shaping its long-term future. Despite how much we've learned, large parts of the universe remain mysterious. We don't know what dark matter is made of. We don't know the true nature of dark energy. We don't know whether the universe will expand forever or change in ways we can't yet predict. Science continues by asking better questions, refining models, and observing more carefully. Uncertainty isn't a failure, it's the frontier. When viewed as a whole, the universe is not chaotic. It follows patterns shaped by simple rules acting over vast spans of time. From particles to stars, from galaxies to the cosmic web, everything is connected through gravity, motion, and expansion. This is not the final explanation, just the current one, and it will continue to evolve, just like the universe itself.